Welcome to this channel, your answer to the very question. This is a concluding part of lens mirror video. In the previous video, we've looked at the nature of image formed by plane mirror and curved mirror. In this video, we are going to conclude our lesson, which is basically for the nature of image formed by lenses. So if you haven't watched the previous video, kindly watch it and make sure you also watch this video to the very end. Without further ado, let's start the video, and at the end of this video we are going to solve the question which I posted in the former video. Another thing that can form image of object is lens. Now we have different types of lenses. Now here we are just going to look at converging lens and diverging lens. Now this lens as shown here is known as convex lens. Convex lens or converging lens. Don't confuse yourself, it's different from convex mirror. Convex mirror is called diverging mirror. Why? Convex lens is called converging lens because it is converging the rays of light. Now, as usual for mirror, any ray of light that is parallel to this principal axis as well will either converge to the focal point or diverge away from the focal point. Now let's see what will happen when the rays of light tries to go through this lens. Now lens is usually a transparent material, glass, it can be plastic that is having a size. Now look at this lens very well. We see that the middle portion of this lens is having a diameter that is more than the tip. Just look at it. It is having a shape that is known as convex. It is convex in shape. Okay, now let's see what will happen when the ray of light tries to go through this lens. The first ray of light will converge at the focal point. At the back of this lens, at the focal point here, is going to converge. Okay, now the second ray will also converge here. The third ray will also converge here. The fourth ray will converge here. Any ray that is moving along the principal axis now will go straight, will not converge. Will not converge. Now the same way, all this one, they will all converge at the focal point. That is why we call this lens converging lens. Is converging the rays of light. Now let's observe the nature of the image formed by converging lens. Now this is where you need to be careful. Convex lens, it is called converging lens. Concave mirror is called converging mirror because it is converging the ray of light. Convex lens is called converging lens because it is converging the ray of light. Okay, any ray of light that is coming here will converge towards the other side, which is towards the focal point here. Okay, now let's see that. Now let's have two rays coming from infinity. When ray is coming from a very far distance, infinity, just like when you want to use lens to observe the moon. Okay, where will the image be formed? The image will be formed at the focal point, just like that of mirror, concave mirror. The image will be formed at the focal point when the rays are coming from infinity. Okay, now what is the nature? The nature will be what? You have an highly diminished image, you have a real image. This is a real image because we have intersection here. Now it is going to be inverted real, and at what? At focal point. When an image is placed beyond center of curvature or 2f as shown here. Now let's draw the image. Now to draw the ray diagram here is quite different from how to draw the ray diagram for mirror. To draw this one is very simple. Now you draw a parallel ray from the top towards your lens, and it's going to what? Converge at the other side towards the focal point. That is the first step. The second step is you are going to draw another ray from the top passing through the center of the lens. You draw another ray from here passing through the center of the lens. So wherever the two rails intersected, that is where the image will be formed. This is what I'm saying. This is your object here. You draw a rail and it's going to converge towards the focal point here. You draw the other ray passing through the center, and the point of intersection of the two rails will be where the image will be formed. They intersected, correct? So we have our image drawn like this, and it's going to be what? Inverted image. It is going to be real. We have intersection of the rays of light. It is diminished. It is diminished, and it is located in between the focal point and center of curvature, in between F and 2F. Okay, let's have an object placed at C or 2F. When the object is placed at C or 2F, now let's draw the ray. The ray will come and converge here. The ray will also intersect like this. Now the image will be formed at what? At 2F or C at the other side. So the image is formed at the other side as well. The image is located at what? At 2F or C, the same position here but at the other side. Now same size as well, just like the mirror, we have same size, inverted, real, the same size as the object, and located in between C and F at the other side. We can see it, we have the same size. So which means magnification here is what? Is 1. The next one, when the object is placed in between 2F or C and F, as shown in between the two, where will the image be formed? Now let's draw our ray, converge, moving like this. Now we see the intersection here as well. What did you observe here? The image is big, is enlarged, is inverted, enlarged, real. Okay, located beyond what? Beyond 2F or C. So you have the image here is inverted, real, magnified or enlarged, located beyond 2F or C. Okay, when the object is placed at F, which is the focal point, let's see what will happen. You should know that this one will also be formed at infinity. Let's draw the ray, convert like this. Now we draw it like this. So where will the image be formed? So the image will be formed at infinity. Yeah, so you just draw it backward like this. So you have the object here, so we have magnified, located at. So now when we have an object in between the focal point and the pole, what will be the nature of the image formed by the object? Now let's observe something here. We have our object as shown. Now as usual, let's draw our ray diagram. We have this one and it's going to converge at the focal point here. Okay, now it is very impossible for us to have an intersection of the rays of light. What do I mean? Now look at the second ray that will pass through the center. As I've explained earlier on, the second ray is passing through the center as shown. Now do we have intersection of the ray? No. Then how do we form image? How is image being formed when we have something like this? It's very simple. Now we just need to trace back the rays of light. We have to trace them back. When we trace them back, an image will be formed. So when an observer tries to observe this lens, we have an image here and is trying to observe the image through this lens. Let's see what the observer will see. Now this is the first ray that is being retraced backward, the second ray that is being retraced backward. Now a magnified, enlarged image will be seen. Now look at the rays that form this image. Are they real? They are not real because we didn't have actual intersection of the rays. Now we just have imaginary intersection of the rays of light forming this image that cannot be projected on the screen. So this is what virtual image. Now we have enlarged or magnified image, so which means the magnification is greater than 1. It is virtual, not real, and it is located beyond the center of curvature. So this image is located beyond the center of curvature. Same side with the object. Another interesting lens is diverging lens, which is called concave lens. Why is it called diverging lens? Because it is diverging the rays of light. Let's see what will happen when the rays of light tries to pass through this lens as shown. Now the first ray of light, which is parallel to the principal axis, will diverge as shown from the other side. Now the second one will also diverge as shown. The third one diverge. Fourth one, which pass through the principal axis, will not diverge as shown. The fifth one diverge like this, diverge, diverge. Observe this very well. What do we have? We have divergence. Divergence. Now all these divergence will appear as if they are diverging from this focal point. They appear as if they are diverging from this focal point. That is why we call this lens diverging lens. Don't forget, concave mirror is converging mirror. Why? Concave lens is diverging lens. Don't forget that. Now let's look at the nature and the position of image formed by concave or diverging lens. Now note this, regardless of the position of objects towards the concave or divergent lens, the nature of the image will always be diminished, erect or upright, and is going to be virtual. Okay, now let's place this object as shown here. Now let's draw the ray diagram. The first ray, which is going to be parallel to the principal axis from the top of the object, will diverge away. Now the divergence is coming from the focal point. Okay, we are still going to see that. The second ray, which we are going to draw, will move and pass through the center, coming from the top of the object. Okay, now we have something that looks like this. Now do we have intersection of the ray? No. So how do we now form the image? How is the image being formed? It's very simple. Call that the divergence of this ray will appear as if it is coming from the focal point. It will diverge away from the focal point here. Okay, now let's try to draw the ray. So which means this is the ray coming from the focal point here. Now look at what we have. We have intersection now. Now look at this intersection. Is it real intersection? No, a virtual intersection. So a virtual image will now be formed when an observer looks like this. So a virtual image will be formed here. Look at the size of the image. Diminished, isn't it? Very small. Now the image is what? Upright, which is also called erect. It is virtual and it is diminished, and it is on the same side with the object. Okay, now how do we solve this question at the beginning of this video? So let's have the solution here. This is a solution. Now this question is very simple. We don't need to calculate this because obviously if we use our lens formula, we are going to get 30. So let's just fix the nature of the image formed by this lens. Okay, in the question, if you read it, we are given f is 10 centimeter. Okay, we're given f, which is 10 centimeter. We are given the object distance. Okay, the object distance, which is u, is equals to 15 centimeters. So you can use your lens formula to get that 30. We are not interested in that. So let's quickly draw our lens. Let's say this is our lens here. We are given the focal length. This is the focal length here to here. This is the focal point. Okay, here to here is 10 centimeter. Okay, now when you double this, you have the center of curvature. Here to here will also be 10 centimeter, and here to here will be 20 centimeter. In the question, we're told that an object is placed 15 centimeter in front of the lens. So we have an object that is placed here like this. Distance from here to here is what? Is 15 centimeter. So which means this object is placed in between the center of curvature and the focal point. Center of curvature and the focal point. And what is the nature when an object is placed beyond the center of curvature? I've given you a clue. The first thing is that it's going to be magnified. Okay, the next thing is that it's going to be what? It's going to be real. Okay, so we have magnified, real. The last thing is that it's going to be what? Inverted. The image is going to be what? It's going to be inverted. So the correct answer here is going to be C. So inverted, magnified, and real. So you can quickly find this 30 centimeter. If you want to find the image distance, it's very simple. You don't know v here, v is unknown, so you should know that 1 over f should give you 1 over u plus 1 over v. Now the focal point of convex mirror is positive, so when you use that, the focal point is positive, and when you insert your value, you are going to get 30 centimeter for that. All right, that is how to solve question like this in JAMB. Please note this very well, and then you are going to excel. All right, if you haven't subscribed to my channel, kindly subscribe to my channel, click on the notification icon, like, share, and comment your view about this video. All right, till then, see you in the next video. Bye for now.